From the massive studios in Raleigh, North Carolina, this is the Cloudcast with Aaron Delp and Brian Gracely, presented by A Cloud Guru, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are. Welcome back to the Cloudcast. We are coming to you live from the massive studios here in Raleigh, North Carolina. You know, you can't kind of be around our industry these days and not run into an article, an event, a meetup, a presentation that doesn't talk about microservices and how you should either break up your existing applications into microservices or write new ones as microservices. And it all sounds great and it all sounds fantastic from like an agile perspective and a going faster perspective. But the reality is when you start breaking things up, you have more things that you've got to keep track of. You've got to figure out how A talks to B and C and dependencies and so forth. And so today we're going to talk about a topic that I don't know that gets enough attention, but it's something that's sort of emerging very much as new applications are being written. So today, very excited to have co-founder of Honeycomb, a company we've been really following for a while, Christine Yen. So Christine, welcome to the show.
Hi, thanks for having me.
So, like I said, we've been, one of our friends, good friends, Anil Lakhani, who's been on the show before, is at Honeycomb. But Honeycomb has gotten a lot of attention because of your background, because of your co-founder Charity Major's background. Give us a little bit of your background prior to Honeycomb, and then why you and Charity decided to start the company and really kind of, start this whole focus around observability.
Yeah. My background, I have been in and out of startups for quite a while now. I'm a software engineer and have worked at a number of small companies that generally got bought by bigger companies. Aardvark got bought by Google, Parse got bought by Facebook, and throughout that journey, including starting a company that was also targeted at consumers and went nowhere. Throughout that journey, I really developed an appreciation for building developer tools, building things where I and the folks I choose to work with have a deep domain expertise, understanding what we're building, why we're building it, who we're building it for. Charity and I actually met at Parse about 5 years, almost 6 years ago now. We met at Parse. She was the head of infra, running ops over there. I came in as a software engineer and built the analytics product. And throughout our time together, as well as through the acquisition, we often crossed paths when we were both in a position of essentially trying to figure out, quote unquote, what was going on. From her perspective, often it was from an ops from her ops seat, trying to debug an outage or trying to dig into, why one of our Mongo replica sets was misbehaving, which customer was causing that, how to mitigate some of the adverse situation, like some of the how to mitigate one customer misbehaving, affecting the others in our multi-tenant setup. From my perspective, as the person building analytics, it was often what was going on and why our analytics were displaying something funny to our customers. Mm-hmm. Often they would be looking at a graph that we very proudly showed them to be like, oh, we'll tell you what's going on with your apps. And they would come and write into support asking, well, why does my graph look like this? What's underneath that spike? Can you tell me more? And we ended up starting Honeycomb. I had left Facebook in the spring of 2015. Charity was leaving in the fall of 2015. And we were chatting about a tool that we had both encountered at Facebook that had made this process of answering what's going on an order of magnitude easier. This tool is called Scuba, and it was the tool that she turned to when trying to figure out what was happening with our system, and it was the tool I turned to when trying to figure out why our analytics, why our the product that we built seemed to be misrepresenting what was going on or insufficiently accurate. And this tool really provided, it made a set of trade-offs around that optimized for speed and flexibility, that made this answering any arbitrary question easier. A customer would write in, and we'd be looking at this graph of, requests per platform. Parse was a mobile backend as a service, so we would show things like, your iOS client is making this many requests, and your Android clients are making this many requests, and often, for example, we have customers being like, well, I know the problem is Android because I only have Android apps using Parse, but which, why is it doing this? And I'd be able to dig in and sift apart this very high cardinality data and tell them, it's this one operating system version of Android that seems to be correlated with this increased number of requests. And it seems to be, these 5 device IDs or something very super detailed and detailed enough for them to be able to go back and triage and understand why their app was behaving in that way. And when we both left Facebook, we were both sort of struck with the fact that this tool didn't exist for folks outside of these large, these large companies who'd had the resources to build it themselves. And we were really struck by the possibility of being able to provide this experience to people outside, because neither of us really wanted to, if we rewound 5 years, neither of us really wanted to go back to a world where we were doing our jobs and didn't have access to a tool like this. Gotcha. No, it makes sense. And we kind of always love to have people on the show who, the thing that they've created sort of wasn't just, hey, we saw a trend, so we decided to do it. It was like it sort of was born out of an actual pain point that they had or an experience, and they said, we would have built this for ourselves, or we used it for ourselves, and so we'd like to make that readily available to a global population. So that's very, very cool. So folks, as you're listening to this, the shows are always half an hour, and we can only get so deep into this. Christine is actually giving a much deeper talk on this at the Velocity conference in New York City. So as you know, we partner with the folks from O'Reilly a lot. If you want to hear her speak about this more, definitely go to the show. There'll be some discount codes in the show notes and so forth. But just wanted to throw that out there as well. If you start listening to this and you go, oh man, I wish they hadn't cut it off at 30 minutes. I want to dig deeper into it. So let's talk about observability. Observability kind of feels like a new term. I think we, for a long time, if you were in ops, you said, well, I have monitoring tools, I have logging tools, I have other things like that. Like what is observability? Is it something that's very unique, or is this kind of just a new way of looking at monitoring? There's an analogy that I think Charity has been using that I really like, where monitoring, think about the word monitoring. It is about, I'm going to set this check for this thing that I know might happen. I know an intruder might come into my house and there might be movement. I know someone's heart rate might go above this some threshold in this known way. And I'm going to set a check for it, and I'm going to watch it. And I'm going to, if this known thing happens, I'm going to be ready and I'm going to pounce on it. That's important. There are many ways that our systems might misbehave or act strangely in a known way, and it's important to have those checks. But as you mentioned in the beginning of this call, microservices are becoming more popular. People are experimenting more with containers, are more tolerant of nodes that might just get killed and new nodes spun up. Our systems are getting more complicated, and along with that growth and complication, we really need to be able to not just watch for these known problems or these known conditions. We need to be able to tease apart and ask new questions of our systems. We can't just keep relying on, hey, is the number of requests made by our Android client within expected bounds? That's not enough. We knew that, we encountered that from the ops perspective, and we encountered that from, like I was describing, my support perspective. We need to be able to go in and tease apart, oh man, is operating system 10.1.2 the cause of this spike? No? Oh, well, okay. What are the user agents tied in? Is there something strange happening with the combination of user agent and operating system? Or from Charity's perspective, is it this customer on this replica set issuing these types of requests again? More and more, there's all these different combinations of things coming into play, and the number of things, if we were to try to approach this from a monitoring perspective, the sheer number of things we would have to monitor would result in millions of metrics, thousands of dashboards that we'd have to scroll through to see, what's going on. Another analogy, and I'm sorry, I'll
no, it's okay. It's good. It's good. No, it's good.
Another analogy we've been hearing and really enjoying using is when you go to the doctor. The monitoring approach almost feels like the doctor has a set of checklists that they're checking you against. Okay, is your arm broken? No. How's your blood pressure? No. Are all of these other things in line? Where they're, is your foot swollen? But that's not how good doctors work, right? Good doctors look at you and they're like, "What hurts? Oh, okay, your chest hurts. What about your chest hurts? Does it hurt if when you do this sort of behavior? Does it hurt all the time? How does it hurt?" Where you're asking these questions and zooming in from this high level "what hurts" question to really get at the root cause, instead of having checklists and surveys that kind of try to paint a picture from based on past work. Right.
Well, and it makes sense. I mean, if we put it in the context of microservices, for example, right? It's a thing. We've got some development patterns that help us build microservices, but the way that they're going to break and how people are interacting with them now with, mobile devices or, AI making a decision in the back end or whatever it might be, like there's not enough sort of history built up of exactly what those usage patterns are always going to look like, especially what the failure patterns are going to look like. So it makes sense that we're now sort of having to unlock a different way of thinking about how are we going to keep track of these things and ultimately, diagnose them and hopefully, fix them and so forth. So it makes sense that, we're still in these earlier days of saying, hey, we're building the applications different. So the systems around them are going to end up having to be, are going to have to be different in new ways that we haven't necessarily thought about before.
Yep, absolutely.
So the more I was digging into it, I kept seeing this reference to, as we get into distributed systems, it's very difficult to give sort of a binary answer, a yes or no to, is the system up? Can you dig into that a little bit? Like why are, if something's up, you'd sort of say, well, I can ping it, or I get a response. Like, why is that not necessarily the case anymore? Maybe versus what we used to see in the past.
Yeah, I love to tell this story. So again, a lot of our drive for Honeycomb came from our time together at Parse, and one of the things that Parse experienced really painfully is Parse is a platform with a huge variety of different apps sending us traffic, and I think at the time of acquisition in April of 2013, we had about 60,000 different apps on our platform. By the time Charity left, that was over 1 million different apps. These apps could be write heavy, read heavy. They could be syncing their entire state every second. They could be having very targeted writes and reads. And what would happen is, again, with 60,000 of anything, you can't have a separate check for each of them to make sure that they're healthy and that their requests are completing in a reasonable amount of time. So we had our top level metrics. We had those on a wall. Top level metrics are still useful to have monitoring checks for, but if we purely relied on that approach, we had no ability to respond to, for example, salesperson coming to us saying, "Hey, Disney wants to try us out, but all they've got a trial going on, but all of their requests are failing. What's going on? They think Parse is down."
Yeah,
and we needed something that would let us, we had our tests, we had our monitoring checks, but we didn't have the ability at the time to actually say, "Hey, what does the service look like from this user's perspective?" and this all ties into, as our systems are getting more complicated, the answer of, or answering the question of, was parse up, is my service up, is complicated by what are other tenants on that system doing? What is my database doing? What is consuming resources that might not be checked for in this other situation? And ultimately, we could point at our graphs on our wall as much as we wanted, saying, "Hey, look, our graphs are green, parses up," but from that user's perspective, it wasn't, and that was causing friction with this deal. That was causing these users to be unhappy. There's some, I think there's a Zazzle site or something where there are these mugs and T-shirts being produced based on something Charity said on stage once, which is nines don't matter if your users aren't happy.
Yeah.
Right. Ultimately, upness, reliability measured by your pingdom check doesn't matter if when your user issues this particular type of request under this other pattern of traffic, it doesn't, and they just always fail. Your availability doesn't matter.
Yeah.
And there's been this movement of trying to remind people to think in terms of, what does my end user see? What does the actual business matter? What actually matters to the business, not just, is my pingdom check returning 5 nines? Right.
No, that makes a lot of sense. And again, it's, we now live in a world that's so, everybody's experience on the web is going to be a little bit differently, a little bit different, whether it's, the type of device you use, but ultimately, you want to have this feel of this experience was specific to me. It worked a certain way. And then you've got expectations of it just, flat out working all the time too. So it makes sense that there's got to be a deeper level of granularity to be able to figure out what's going on. Why is somebody upset? Why are we seeing certain things? And, so let's dive into the platform a little bit. Obviously, this is probably a conversation that's better in front of a whiteboard, but at a high level, Honeycomb collects data in lots of different ways. They could be log data. It could be, an agent. It could be monitoring an API. It could be a lot of things. That data all comes into your system. What has to go on in a system like that, especially from tons of different applications, users, companies, in order to make it useful? What are the high level things that you have to do that you expect from the data in order to make useful information out of it?
I'm glad you asked. We expect data that comes into the Honeycomb platform to be structured and not pre-aggregated. One of the things that a lot of systems, metric-based time series, pre-aggregated metrics systems rely on is doing a lot of aggregation on the client, saying, oh, I'm just going to increment a counter over here in order to provide speed in returning analytics to the customer. We rely on not pre-aggregated data, but data that is structured, so you can tell us, these are the keys, these are the values. And we take that and we shove it into a distributed column store that is super highly optimized for being able to return fast analytics in a very flexible way. And this lets us essentially give folks the flexibility that they're accustomed to, for example, getting out of their logging tools, being able to break down or filter by anything that they think of rather than what they defined ahead of time. But being able to get a performance characteristics out of that are unlike anything that you would get, grepping over unstructured text.
Okay. No, it makes sense. And again, there's always going to be some trade-off between how I send you the data, how it's represented, and then how much work you have to do to make it, useful. And so that's good to know. I don't think I'm kind of stepping over the bounds when I say that, Charity's a unique personality. And one of the things that I always find, she speaks at a lot of events, and I'm sure there are people who are going to go and they're going to Google Honeycomb, and her talks are going to pop up. And a lot of times her talks, because the two of you have so much kind of real world experience with live web scale environments, they come across sometimes as man, that's kind of crazy. That seems, contradictory to what we see sometimes, in sort of mainstream IT. And I know one of the things she's been talking about lately is you need to test in production. Can you give folks a sense of like what is test and production? That sounds insane. Like why would that line of thinking come along? What does that do to help a company?
Absolutely. The important thing to remember here is when she's saying testing and production, she is not saying only test and production. Mm-hmm. It is not test and production because you didn't previously. It is great. You've written your unit tests, your functional tests, your integration tests, all the tests locally that you needed to write to make sure that they work in isolation. Now let's also apply that mindset to after you've shipped your code, after it's deployed. Let's apply a testing mindset to it to make sure that things are actually behaving the way you expect them to, that the same thing that you believed would be correct locally is also correct in production.
Okay.
And I'm glad you asked about this because this is a large theme in our velocity talk or workshop. It's this mindset of, okay, what should I be doing? I, as a software owner, whether that is the person who wrote the code, the person who is operating the code, is ultimately, we believe that we're approaching an era where people are, those roles are blending. And there's a software owner who is just responsible for making sure that code still works. And testing in production is encouraging people to think about, okay, well, what if you had the same sort of visibility in production into what your code is doing, how it's doing it, that folks are accustomed to in their debugger during tests.
Okay.
And a lot of that means, if you start from a very concrete example, an end-to-end check is a simple form of a production test. What that end-to-end check actually does very heavily depends on your system. To use an example from the Honeycomb world, our end-to-end checks that we use to make sure we're still behaving correctly, they write a payload to Honeycomb, and within some certain amount of time, they expect to be able to read that back. And this is kind of what we boiled down to. This is the bare minimum of what a customer should be able to see work reliably for them to consider Honeycomb as being quote unquote up. And so we have that end-to-end check written, and we also have kind of paired with end-to-end checks, we have instrumentation and observability to be able to immediately jump in case that end-to-end check fails. Because when that test case, when a test fails locally, you dig in, you plug in your debugger, you add log lines, whatever you need to do to figure out why something is failing. In production, it's a little bit trickier. And so by saying test in production, we're saying, hey, okay, what do you need to do to figure out why something is failing? And think about it a little bit beforehand so that you can be ready. I really think of kind of observability as a strategy for that sort of debugging in production, instrumentation as a tactic. And so that means for our end-to-end test, going in and making sure that we have hooks telling us, hey, what failed, when, how did it fail, from the end-to-end check perspective. And from the server side, having the ability to say, oh man, okay, this end-to-end check failed. What else was happening when this end-to-end check failed? Is that failure unique to just the check? Is it happening elsewhere to other customers, to other workloads? And that's really what we're going for. We're telling people test in production and be able to debug those tests by demanding to have the same sort of visibility that you have locally when you're talking about production machines.
Gotcha. No, it makes a lot of sense, and I appreciate the sort of clarification for it because, like I said, on the surface you go, wow, that sounds. It's sort of an interesting perspective, but no, the clarification is very, very helpful. I'm going to sort of wrap it up with one last question. One of the things I like to do, especially with new companies, with startups, is go out to the webpage, go look at some of the customers that they reference and so forth. And I always look to see, are their customers sort of just local Valley companies or just other brand new startups, or have they sort of migrated out to a broader set of customers? And so I was kind of I was gravitated towards, you have Fender guitars as one of the customers that are on your website. And, Fender guitars been around for a long time, and not necessarily, you wouldn't necessarily think of them as a technology company as much as, kind of a craftsman company. I mean, obviously, music is its own industry, but it's not, the building of the guitars and so forth isn't necessarily, a Silicon Valley company. Can you talk a little bit about what a non-Silicon Valley company is doing from an observability perspective? Like, why would, what are they doing that needs observability? Absolutely.
So Fender, I love as an example for the exact reason that you describe. It is a little bit, it's easy to think about platforms like Parse, like many of the other companies we work with, as having observability problems. But they have, ultimately, this is cliche at this point, but software is eating the world. Mm-hmm. Every company has a software team. Every company has servers or software that is running that they need to be able to debug when things are going wrong. And a lot of these things are going wrong in production. And Fender, one thing I want to point out is, while observability is certainly talked about a lot in conjunction with microservices, observability, the most exciting part about this is that, or rather dirty little secret, is that it is not only useful to people with observability. Only useful to people with microservices. Okay. Plenty of people who have monoliths have a lot of the same problems and often more, where they need to be able to dig in and find out what's happening in production. That was a caveat. Fender in particular is actually incredibly tech forward. They are very vested in the serverless space. They've got a lot of, they have a number of Lambda functions running in production, and they are using Honeycomb to tease apart the data that they're getting out of CloudWatch in order to figure out what's happening with their logic. And they are doing a lot of trying to tease out, again, the same sorts of problems you would if you were some other Silicon Valley e-commerce company. What's happening with subscriptions? What's happening with these things that are really important to my business? Why are they failing? Or why are they behaving in a certain way? Why is it taking our customers longer to complete their purchases? And when we started the company, we knew there was going to be a lot of, we were ultimately trying to change how people thought about observing their systems, monitoring their systems. We were trying to cause a behavior change. And we knew that part of the key in building a successful business off of that sort of thing was being able to reach people who were, east of Fremont. And it's so exciting to be able to have customers who are able to hear what we're saying out as we're talking at conferences and posting blog posts, to hear and be able to self-identify, hey, I do have that problem. Oh, man, the old way and these old tools I'm using just aren't quite cutting it now that I'm in a world with containers and no servers and things like that.
Interesting.
And Fender they've been great customers, and I'm glad you picked them out to talk about on this call.
Yeah, no, that's very, very cool to hear. I mean, we're based out here in Raleigh, so we're always looking for things that we know the technology is coming out of the valley, but we're always looking for uses outside of kind of sort of like you said, the 280 or 80 bubble. So very, very cool to hear what they're doing. Well, listen, with that, I'm gonna kind of wrap it up. What's the best way if people want to engage with Honeycomb to try the technology, get in touch with your team, just engage with you in general?
Absolutely. If folks are interested in trying out our technology, we have a free trial. It's a 1-month trial, and once you have an account, you can go play around with our demo data set. We've got a nice little tutorial that walks folks through sort of the mechanics of playing around with demo data. But we have a ton of really great integrations that make it easy to get your data in, so please try it out. Give us a shot. We're around on chat and email, and always around on Twitter.
Very, very cool. Well, listen, Christine Yen, co-founder at Honeycomb, thank you so much for the time today. Really enjoyed the conversation, and hopefully folks learned a little bit more about observability. And like we said, if you want to really dig into this some more, she'll be speaking at the Velocity Conference in New York here, coming up pretty soon in June. For that, for Christine and for Aaron, I want to thank everybody for listening, and we will talk to you next week.
Thank you for listening to the Cloudcast. Please visit thecloudcast.net to find more podcasts, show notes, and everything social media. And visit acloud.guru for all your cloud training needs.